Hey there, ladies and gentlemen, boys and girls. Today we are I'm going to show you guys on how to properly draw atoms. Now that we know a little bit about what our atoms are made up of: protons, neutrons, electrons. We've been able to count them, how many protons, neutrons, electrons. Now we can actually draw a model or a visual representation of what the atom looks like. All right, but quick caveat real quick. All right, now we know that protons and neutrons are in the center of that nucleus, very, very small, very, very dense, surrounded by these clouds of electrons. All right, there's different levels of clouds of these electrons. Now, when we're drawing atoms, right, drawing these fuzzy cloud-like regions where electrons can exist, it's really hard to represent that. So what we actually do when we draw atoms is we have our nucleus. And then we actually revert, for the electrons, we actually revert back to a simpler model known as the Bohr model, the one that was created by Niels Bohr, also known as the planetary model. And the only reason why for that is simplicity's sake. It makes it a little bit easier to see our atoms and understand what's happening with the atoms in a simpler model than it is with our more advanced model, what we also know, the more advanced model today, also known as the quantum model. Quantum mechanics is just a little bit tricky. All right, so I'm going to show you guys how to draw today the planetary model or the Bohr model for a couple atoms. It's really just a couple set of rules, and really just following it. And the more you do it, the easier it gets, and it goes pretty quickly, I think, here. So I'm just going to I'm going to do two examples here, and kind of go through the process of things you need to pay attention to. So make sure you guys have out your handy-dandy notebooks, and you are ready to kind of write some of these down and go through that process when you do some practice drawing atoms on your own. All right, so let's do a couple of, or let's do two of them here. All right, first let's do, first one I want to do is, we're going to do carbon. Which of course is the letter C. All right, so let's first do carbon. So I'm going to start with my number of protons, neutrons, and electrons. It has 6 protons, mass is 12. 12 minus 6 is 6 neutrons, and we are doing neutral atoms as of right now, so these two numbers are going to be the same. All right? So what we're going to be focusing on today, we've talked a little bit about protons and neutrons, but the one we're really going to be focusing on today is the number of electrons. So right now, remember, like I said, we're doing neutral atoms. What is a neutral atom? That means if I have 6 positive protons, I need to have 6 negative electrons to cancel out to be no charge or 0. Think of it like a positive and negative kind of canceling each other out. If I have 6 positives, I have to have 6 negatives to cancel each other out. That's what we're doing right now. All right. So even though the nucleus is still definitely there, we are going to be focusing mostly on this model with the electrons, because we're going to eventually start leading into how atoms interact with each other. How does a carbon atom relate to a hydrogen atom? Well, if the parts on the outsides are what's going to interact first, because they're on the border, the outsides. So we're going to focus on those things, those electrons. All right. So again, just to make some things kind of easier, I'm going to draw my nucleus. I'm going to draw it like this. I'm going to draw a little bit bigger there. All right. There's 6 protons. I put a 6p, 6 neutrons, 6n for neutrons. All right, just real straightforward for right now, just keeping it nice and easy. All right, now I need to draw my electrons. All right, I need 6 of them. And they are going to be outside the nucleus in those orbits, all right, in those cloud-like regions. But like I said, we're going to simplify the model a little bit. We're just going to draw them kind of in almost like planetary orbits, like this being the sun. All right. We're going to start drawing orbits. Now, these orbits are actually more specifically called energy levels. All right? The one closest to the nucleus is called the first energy level. All right, that's our first energy level there. Each energy level can only hold so many electrons. The inner one is actually one of the weaker ones in the fact that it can't hold that many electrons. All right. In fact, it can only hold a maximum of 2. It can hold 1, but it can only maximum hold 2. All right. So I'm going to draw 1 here. That's my electron. I'm going to draw 1 here. All right. I'm going to draw them like that. All right. So it holds a maximum of 2 electrons. Holds 2 electrons. All right. It holds 2 electrons, but we're not done. It can only hold 2, but yet we need to have 6. So we need to have 4 more electrons. So what we have to do is once that energy level is full, we go to the next energy level. This would be obviously the second energy level then. Second energy level. All right. This one has a certain amount of energy too and has a limit. It can hold 8 electrons maximum. We don't need to do all 8 because again, we only need 6. So I've done 1, 2, 3, 4, 5, 6. So I have a total of 6 electrons here. All right. I have a total of 6 electrons. 4 of them in the second energy level, 2 of them in the first one. A lot of people ask, do I have to do kind of the top, right, bottom, like that? It's a good habit to get into, and we'll talk a little bit about that more when I do the bigger example next term. It's a good habit because it makes the next things a little bit easier to do, the next step from beyond Bohr models. It doesn't matter, but it does make it, for right now, it doesn't matter, but it will help later, kind of doing the stuff like this. All right, so now we are done. We have our 6 electrons, right? 2 in the first energy level, 4 in the second energy level. Pretty straightforward. All right, we could have put more in the second energy level, but we didn't need to. All right, so here let's go and let's do another one here. Let's do magnesium. All right, just gonna write it up here. Magnesium. All right. So let's start with a number of protons, neutrons, and electrons. I look up on my periodic table. I see I have 12 protons, which means I have 12 electrons for right now, neutral atom. And 24.3, that rounds down to 24. That's going to mean 12, 12, 12. All right. Again, we are obviously, we have to consider the neutron, or the nucleus is still there, but our main goal is going to be talking about the number of electrons here today. All right, so I'm going to put my nucleus here, 12p, 12n, right? Now I need to do 12 electrons. You always start with the inner energy level. You always start with the first one. If you fill that up, you go to the second one. All right, so I'll start at the first energy level. 1, 2. That energy level is all full. I'm going to have to go to the second one. All right, so I have 2, 3, 4, 5, 6, I'm trying to get to 12, 6, 7, 8, 9, 10. Okay, I'm at a problem here. I only have 10, but I can't add 2 more to the second energy level because if you remember, that second energy level can only hold 8 electrons. I have 1, 2, 3, 4, 5, 6, 7, 8 electrons right now, which means we have to go to a third energy level. All right, a third energy level. I have 10 right now. I need 12, so I'm actually only going to do 1 and 2. This third energy level here. It can hold a maximum of 8 electrons. I didn't need all 8. I only needed the 2. But that gets me going there. So this carbon atom uses 2 energy levels, has 6 electrons. This one had used 3 energy levels because you can't move on to the next energy level until you fill in the previous one. So I filled up the first one, moved out to the second one. I ended up filling that one up. I had to move on to the third one. Now I'm at my final place here. All right, now there's one more thing. I said at the very beginning that if we're going to talk about how these two are going to interact, with atoms are going to interact, so if I was going to put a carbon and a magnesium near each other, the first things that are going to touch when they come near each other are the electrons. But more specifically, the outermost electrons. All right, the outermost electrons. Those are what we call valence electrons. Valence electrons. That's a big one. We're going to be spending a lot of time talking about these guys. These are the outermost electrons. The outermost electrons. All right? Which means this one right here, this carbon atom, has 6 electrons. 4 of them, VE for valence electrons, it has 4 valence electrons. 1, 2, 3, 4. 1, 2, 3, 4. It's just a name that we give to the electrons on the outer side. They're not any different than the inner ones. They're just on the outside. All right. So I look at this one here. Right. It's got a total of 12 electrons, 10 on the inner levels, 2 of them on the outer levels. So this magnesium atom has 2 valence electrons. 1, 2. All right. Okay. So in the end, what you got to be able to do is if I gave you an element, a neutral atom, say oxygen, can you draw it? And then can you identify the number of valence electrons, or those outermost electrons? All right. So that's how we're going to draw Bohr models here. This is a lot of just kind of practice, getting used to it. Once you do a couple of them, it gets pretty straightforward. And for those who just kind of a little heads up, there is a pattern on the periodic table that it shows you exactly how to draw or what the Bohr model should look like based on the periods and groups. I wonder if you can figure it out. All right, as you start drawing them especially. All right, otherwise, thank you for watching. Good luck, and may the science be with you.